Let's see, everybody. In IUPAC, the next topic we need to learn is how to write the multifunctional IUPAC names. That is, if you have multiple functions, one of them will be the main chain, and then rest will be the substitutes now. So we will not be calling every functional group which is important in this case. Okay. So let me show you a few examples here how to write the multifunctional groups here. See, in the first case, while writing the name for this one, first you need to prioritize. There are three functional groups here. So one is carboxylic acid, ketone, and aldehyde. Priority wise, carboxylic acid is first preferable. Therefore, numbering should be always starting from that and longer, try to reach towards the longer chain. So therefore, this is the 5-carbon chain here. So which means it is a pentanoic acid or pentane enoic acid because of the ene present here. So now, what do we have here? On second position, we have oxo, and third position, we have formyl. So we will go with that writing. Okay, so 3 formyl and 2 oxo, and this is pent 4 enoic acid. So it is 4 enoic acid. Everybody clear? So that's how you'll decide the functional group, and then rest of them will be the simple substituents. Okay. Again, the same logic here. We have an ester, we have cyanides and hydroxy groups. So main functional group is esters. Esters is high priority in terms of cyanides and OH. So if you compare the naming here, again you will start with 1 here, 1, 2, 3, 4, 5. That's where you will stop it. Now as a cyanide, you will take this as two different functional group. Do not count this carbon as well. So now we have total 5 carbons. And while writing esters, if you recall, I need to write the alkyl name first. So which means it will become methyl, right? After methyl, we start with 5. Sorry. Yeah. Now, if you notice that this is cyano and this is isocyano. So these two are two different functional groups. On fifth position, we have cyano. And on third position, we have hydroxy. And on the fourth position, we have isocyano. Isocyano. I have written it in the alphabetical order. And then we have uh, pentanoic acid. Sorry, pentanoate. Because it is an ester, you have to write it as O8. So please check the naming, everybody. We have written this in an alphabetical order. So you remember that in esters, the first name should be always the alkyl name which is connected onto the oxygen side without any numbering on it. Okay. See, the next naming will be about, you know, functional group here. The main functional group is carboxylic acid here. So this will become 1, then 2, then 3, 4, 5. And the other side will become only substituent. So what is the substituent here? 1, 2, 3. So it is 1 dash, 2 dash, 3 dash. So this is basically propenyl. Okay. So this is a propenyl case. So we have on second position. On the second position, we have hydroxy. Second position, we have propenyl. And for propenyl, again, we have on the second position hydroxy. So 2 hydroxy, propenyl, prop, in, yl. Got it? And that is connected to penta having 2, 4 diene acid. Dienoic acid. Okay. So that would be the naming for this one. I hope all of you are writing simultaneously. So please do check. This is the name for multifunctional cases. Let's write the next one together, everybody. There are three functional groups: ketone, aldehyde, as well as hydroxy groups. And you know that out of these three, ketone is more priority functional group. So now I will be starting from here. Now here is the important part, everybody. You can go from anti-clockwise direction or you can go clockwise direction. You should, because the locands are at the same position, you will check out alphabetically which one will come first. If you go anti-clockwise, you will get hydroxy first. So therefore, you will go anti-clockwise direction in this case. Okay. And there you will write down 3 hydroxy, 3 hydroxy, 5 oxo, cyclohexane, complete name, and carbaldehyde. So that is the name for this compound here. Okay. See the next one here, which we have. Now, between aldehyde and cyanide, cyanide is a high functional group, high priority functional group. Okay. Now, here is the interesting thing about cyanides. If you start from anti-clockwise direction, the double bond is getting at a much higher locant. Once you decide the functional group, your next objective should be to give the lowest locant to the double bond. So always ensure that the double bond is getting the lowest locant. So in that sense, if you notice, you have to start numbering anti-clockwise direction like this. Now you can see cyanides are the highest priority, and thereafter double bond is getting at the lowest uh, locant value. So now what is the name? We will have fifth position formaldehyde or formyl on fifth position. Then we have cyclohex, cyclohex, 3 in, complete in you have to write, and then we have 1 comma 2 dicarbonitrile, dicarbonitrile. That will be the name. 5 formyl cyclohex, 3 in 1 2 dicarbonitrile. Clear everyone? See the next one here on this case. You have hydroxy, amino, methyl chlorides are always substituents. So on the priority basis, hydroxide is the most, high priority functional group here. So if I start numbering here, so I'll start with hydroxy first, then going for the lowest locant of double bonds. So that is how the priority should be. So this is the numbering which you will have to give it. And now you know that on fifth position we have chloro as well as methyl, and sixth position we have amino. Alphabetically, amino comes first, so amino, 6 amino, and on the fifth position I have chloro. Sixth position we have chloro, and same fifth position we also have methyl, 5 chloro, 5 methyl, and this is cyclohex, 2 in all, 2 in all. Sorry. I hope this is clear, everybody. See the next one. Right. In here again, if you notice, the main functional group is amine here. So we'll be starting with amine and try to go for the lowest locants. The lowest locants is possible if you go clockwise. 5, 6. So that we will have 2 bromo, okay, 6 chloro, and 3 methoxy, 3 methoxy, cyclohexane, okay, hexane, and amine, hexanamine. Please check everybody. If anybody has a doubt, they can ask me again. Please do check all the names properly. Done. Next, let's see how do we write the IUPAC naming for compounds known as bridged forms and spirofunctional groups. The bridged forms, whenever we use the word bridged, we have mainly two types of bridges. One is fused bridge, the other one is bridgehead bridge, which means if you compare those, if you notice the two cyclic structures, connected this way, but in between them there is no carbon, then that is called the fused form. Okay. If at all between the two functional group there is more number of carbons present in the bridge, across the bridge we have more carbon numbers present, then it is called bridgehead forms. So we will have bridgehead cases here. So in such cases, right, when you have a bridged compounds or two cycles are connected to each other this way, then the numbering of bridged cases, how to do it, what is the priority that need to be taken. Let's see that. First is number also from the common carbon points, right? You should always start numbering from the common carbon points, which means this one, the bridge positions. So these are the common carbon positions. The numbering should always start from here, irrespective of whatever functional group you have. Agreed? So irrespective of whatever with the functional group is, you will always start from here. Second, you have to mention how many number of carbons are present on the left side, right side, and center. Okay, how many on the left, how many on the right, how many on the center. Correct? But in what order you need to mention? You have to always mention in the decreasing order. Okay, highest first, then towards the lowest. Let me tell you how. For example, these two are the common points. With these common points, have you noticed left side I have highest number of carbons? How many? 1, 2, 3, 4. So that is the first thing you will mention, that there are 4 carbons. And next on the right hand side, how many we have? 2. 2 carbons. That is the next priority. Between the bridge positions, are there any carbons? No. So 0. So all these three numbers should be mentioned. So 4, 2, 0. Always highest towards lowest. Now you might ask, sir, is it always left, right, center? No, it could be right, left, center. Correct? It depends upon whichever has the highest number of carbons. Everybody understood? So it should always from the highest towards the lowest. The numbering of the carbon should also go in the same sequence. That is, where there is a higher number of carbons, you should always go towards that, finish up to the ring position, and again come to the next lowest number of carbons, and then to the next lowest number of carbons, which is bridgeheads. Okay. See, in this case here, for example, you should always number first from the center here. Now, listen, everybody, check out. Suppose for this example, if at all I have to start numbering, let us do it together. Suppose we are starting first with here 1. So where should I go? First, I need to go left only, because bigger number of carbons are on the left hand side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now tell me, where is the double bond coming in this case? If you go in this sequence, it is coming at 8th position. Correct? Now let me take the other route this time. That is, let us start 1 from here. So 1, 2, 3, 4, 5, 6, 7, 8. Now where is the double bond coming? At 7 position. So this is more prioritized. Clear? So therefore this will be the correct naming here. Now how do we write IUPAC name? Because there are two cycles present, you will mention it as bicyclo. So first you have to mention it as bicyclo. And then left hand side we have 4 carbons, right hand side we have 3 carbons, center we have 0 carbons. So this will become bicyclo 430. Then total number of carbons are 8, so it is oct. On 7th position there is an ene. So this is oct 7 ene. That is the IUPAC naming. I
So
guess
can
all
you
of you
explain
understand.
the 430?
Yes, beta. See, you have to first, this is the common points, right? Common carbon points. On the common carbon points, you have to notice either left, right, center. Center between 1 and 6, how many carbons we have? 0, right? And on the right hand side, how many we have? 3, right? On the left hand side, how many we have? 1, 2, 3, 4, right? So which is the highest number? 4, है ना? तो 4 पहले लिखने का. So first it will be 4, then 3, then 0. Okay. So then you will write the numbering. Then you write the name. So it is total 8 carbon. So it is oct. On 7th position, there is ene. Everybody clear on this point? Right. See the next one here. Suppose if you check out this case, how many carbons we have? 1. You have, this is the starting point. 1. Then left hand, these two are the bridge positions, correct? On the bridge positions, left hand side I have 1, 2, 3, 4 carbons. Right hand side I have 1, 2, 3, 4 carbons. Center I have 1 carbon. Now this time center also I have 1 carbon. So how do we name it here? First let me write all the numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you go towards the next numbering, which is 11. So chloro है ना 11th position पे है. In total we have 11 carbons, everybody. Here. So what will this become? 11 chloro. सबसे पहले substituents को represent करेंगे. Then we will write bicyclo. And we have 4, 4, 1. And this is undecane. Okay, undecane. 11 is undecane. Clear? Sir, doesn't the previous one is no name? How many carbons you have? You need to check, Ayushi. Check out how many carbons we have, beta. Total 6 here. Sorry, 9 is there, right? My mistake. Sorry, no name. Yeah, no. Yeah. Everybody, please check. This is non-heme. Total 9 carbons we have. So it is non-7-heme. Okay. Thanks, Ayushi. I guess everybody understood bicyclo, how to write that. Let me give one more example. Please try this one. I'll write on here. So if you have it like this. Sorry. If you have it like this, then how do we write this, everybody? First, decide on the bridge positions. These two are the bridge positions, everybody. Notice, these two are the bridge positions. On the bridge positions, notice how many on the left, how many on the right, and how many on the center. See, 1, 2, 3, 4. 4 on the left. correct? How many on the right? 1, 2, 2 on the right. How many on the center? So 1, 2, 3, 3 on the center. Got it? So now, how do we need to go for writing? See, you need to give the double bond more priority, correct? While writing the number while giving the locands, double bond should come at the lowest value. Let me first give you both numberings, everybody, starting from here. Let's see, 1, 2, 3, 4, 5, 6. Is 7, 8 correct? No, right? ये करेक्ट नहीं है. क्यों? फर्स्ट बिगेस्ट नंबर ऑफ कार्बन की तरफ जाना है, उसके बाद नेक्स्ट बिगेस्ट, उसके बाद देन यू हैव टू गो टुवर्ड्स द लोएस्ट नंबर. So 7, 8 going he is wrong. So I have to go like this. Then I have to go, so after 6 I have to go 7, 8, 9, then 10, 11. Okay, correct? This is one way. Or on this, sorry, I can write 10 and 11 here also. 10, 10 and 11. Okay, got it? In this case, where am I getting the methyl on third position and double bond on 10th position? Correct? Suppose if at all I write the other way around, like this. If I go this way, 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11. Again, you're getting the double bond irrespective of this way or that way. Double bond is always coming at 10 position only. You cannot avoid that. Okay. That is the best you can get. But unfortunately, methyl here is coming at 4th position. So is this correct? No, earlier one is only correct. So let me redo that part here, what we had earlier. Okay. This one is correct now. So I guess all of you understood how to write that. So now notice. So what is the substitute? We have 3-methyl. Then I have bicyclo. I would have highest number is 4. The next highest number is 3. Next highest number is 2. So 4, 3, 2. 4, 3, 2. And then total number of carbons are 11. So undeck, 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 decan. And what is the one here? Because it is in ketone, 10 one. So that is the name. Utsa, that's correct, beta. I hope all of you understood how to write the fused forms as well as bridged head forms. Next, let us understand spiro. Spiro is the word used when you have only one carbon, single carbon, which is separating the two rings, or that single carbon is the common center for two rings. So in that case, the numbering should always start from the adjacent carbon, not on the central carbon. It should be any adjacent carbon. So listen, numbering can start from here, 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 or here. These 4 positions are the ones where you can start numbering. Okay. And it is exactly the opposite way of bicyclo. Now, you should give you lesser carbon chain as more priority. And the sequence should be from lowest number of carbons to the highest number of carbons. This is exactly the reverse of bicyclo, everybody, while giving the numbering. So check out. If this is the case, we have a 3-membered ring and a 6-membered ring. You should always start with 3-membered ring. So from the adjacent carbon. So 1, then 2, then 3, then continue 4, 5, 6, 7, 8. So that is the numbering we have. And instead of bicyclo, now we write spiro. So spiro 2, 5. So there are two carbons on the right, five carbons on the left, then octane. Everyone clear? And see the numbering here again. Here, left side we have six carbons, I mean five carbons. Right side we have four carbons here. So numbering should always start from adjacent carbon with the lowest carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Listen, 5 के बाद है ना, आप ऐसे भी जा सकते हो एंटी क्लॉकवाइज, or you can go clockwise also, clockwise or anti-clockwise, depending upon whichever is the lowest locant which you can get. So going anti-clockwise, we are able to get the double bond at the lowest locant. That's why we are going anti-clockwise direction. Hence, what is the name? Spiro 4 5, correct? Because right side we have 4, left side we have 5 carbons. Then total number of carbons are 10. So dec 6n to all. That is the Spiro name, everybody. Clear? Do check the next one, everybody. Try it on your own. What should be the name? Where do we start from? See if you got the same numbering. Correct, everyone? I hope all of you got the same numbering. Okay. 1, 2 could be down and up or up and down. Doesn't matter. Okay. There is no functional group as such here. So therefore, we have 5-methyl. So we have this as 5-methyl spiro. Right. This as spiro. And then 2, comma 4. 2 on the left, 4 on the right. And then it is hept 5-ene. That's it. That is the name of this compound. Okay. So I hope all of you are clear with bicyclo and spiro cases, how to write the IUPAC names. All right. Next, let us understand how to write the ether IUPAC names. Okay, ether as such is not a functional group, but if there is nothing present, but only ether is the molecule, then how do we name it? See, in that case, the oxygen including the carbons together is always called as alkoxy. Alkoxy. So alkoxy is a substitute you will read. Just like if there is a chlorine, what do we read? Chloro. Bromine is there, bromo. NO2 is there, nitro. NO is there, nitroso. Like that, OR is there, you read it as alkoxy. So if it is methyl, methoxy, ethyl, ethoxy, and so on. So you can see left side I have a ethyl and right side I have two carbons. So therefore it is ethoxyethane. Clear everybody? That is the IUPAC name, ethoxyethane. Okay. The common name, CN, the common name is diethyl ether. This is how you will write now. Okay. DEE, diethyl ether. Okay. Wherever you see something like DEE, that means it is diethyl ether. Common name. Okay. Next, here, if you compare one, see, 1, 2, 3, 4. This is the longest carbon chain on which there is a substituent. What is that? Methoxy. And IUPAC, I mean, numbering wise, this is how you name it. 1, 2, 3, 4. So on second position, I have methoxy. So it is 2-methoxy, 2-methoxybutane. Clear? It is 2-methoxybutane, everybody. Likewise, You can see here IUPAC name wise it is 1, 2, 3. On that I have, what is this one? Isopropoxy. So on one position I have isopropoxy, then it is propane, isopropoxy propane. Next one, I have a methoxy on benzene. So it is simply methoxybenzene. 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 The common name is anisole. Anisole. We'll be using this a lot of times. So remember, the common name for that is anisole. This one is ethoxybenzene. Ethoxybenzene. The common name is phenetol. Common name is phenetol. Okay. Now, here is the interesting one. Everybody makes usual mistake here. There are two names which you can write. One is with respect to benzene. One is with respect to these carbons. So, benzene can always be read as substitute also. Therefore, numbering should start from here. So, 1, 2, and 3. On third position, we have phenoxy. This entire thing can be read as phenoxy. So, the name should be 3-phenoxy 3-phenoxy. This is propene. 3-phenoxypropene. I hope all of you have written this. These are easy ones. You just need to understand from where the oxy should be generated. Now, these are few terms which you need to know. Okay. While we discuss the ethers chapter, you will come across this a lot of times. But anyways, you have to check this. See, if you have uh, cyclic ethers, right? In a cyclic ethers, there were two ways of writing it. One, you can write this as an alkane. 1,2 is an alkane, which is ethane, with an oxygen connection. The connection was earlier represented as epoxy. So it was 1, comma 2 epoxy ethane. This is an old IUPAC way of writing. Same way here, this is 1, 2, 3, correct? So according to old IUPAC, it should have been 1, 2, 3, which is propane at a connection of 2, 3. Sorry, 1. This is 1, 2. I have to write the IUPAC name correctly. See, 1, 2, 3. So we have to write this as 1, 2 epoxy propane. This is the old IUPAC name. Clear? Now, same way here, what is the old IUPAC name for this one? It will be 1, 2, 3. So 1, comma 3 epoxy propane. Epoxy propane. This is the old IUPAC naming. The new IUPAC naming is that you name the cycles itself. The three the three cyclic ring here, heterocyclic ring with oxygen, it is called oxyrane. That's it. You will name it as simply oxyrane. Clear? And if this was the compound, let me write down the same compound back here. Okay. This is the compound we have, oxygen, like this here, correct? Always start numbering from oxygen's end. So 1, 2, 3. So this is the numbering of oxyrane. And on second position, we have methyl. So you write it as 2-methyl oxyrane. This is the new IUPAC name. Now, this is more accepted in exams. Okay. So remember, if old and new both are given, always go for new IUPAC naming. Okay. So it is 2-methyl oxyrane, everybody. Okay. So if it is a 3-membered ring, you call it as oxyrane. If you have a 4-membered ring, the name is oxytane. 5-membered ring, oxolane. 6-membered ring, oxane. You don't have anything above this in the syllabus. So you will only have up to 6-membered ring. So one is 3-membered ring is oxyrane, oxytane, oxolane, and oxane. Okay. Just to give you one example, please check this out. Suppose if you have like this, correct? I have a methyl here, double bond here, correct? So what should be the name in this case? See, this is oxane, correct? This is going to be an oxane. So numbering should always start with oxygen. Then you give more priority to double bond. 4, 5, 6. This is how the numbering should be. So on fifth position, I have methyl. So 5-methyl oxane. There are two ways of writing it. We can simply write it as, 2 in 2 in oxane. Okay, 2 in oxane. Clear? Or I can also write it as 5-methyl, 5-methyl ox 2 in ane, 2 in ane. So this is another way of writing. The first one is more accepted. Okay, so to show the complete name of it, that is oxane is the six-membered ring. So I hope all of you understood how to write the IUPAC name for ethers. What is meaning of epoxy? Epoxy is a wording used for a cyclic ether. Utsa clear beta? Cyclic ether is called epoxy.
Can you go up for 1 second?
Yeah, please check quickly.
Done, sir.
Now listen up, everybody. In case if you have two rings and straight chain, imagine I have two rings and straight chain. In that case, the straight chain will always becomes the priority, irrespective of how many number of functional groups we have, whatever functional groups we have, the straight chain is always the main functional group. Okay, very important. A lot of kids make mistakes here. So if you have two chains connected with a straight chain is the priority of everybody. Hence, the name is 1-cyclobutyl, 1-cyclopropyl, and methane. So methane is the main chain or the root chain. Okay, clear? So what will be the next one's name? Again, we have two chains here. Clear? Correct. Now, since both of them are present, you need to check out alphabetically because this is also six-membered, this is also six-membered. So the six-membered start with C, cyclo. Here it starts with C. Here it starts with phenyl, P, P-H-E-Y-L. So which one should be given priority? C should be given priority. So the numbering starts from here, 1 and 2. So what is the name here? 1 cyclohexyl, 1 cyclohexyl, 2 phenyl, 2 phenyl ethane. 1 cyclohexyl, 2 phenyl ethane. Okay. So students, wherever you see multiple rings, please make sure straight chain as the priority. Next, in case we are writing aromatic IUPAC namings, correct? Like there is simply an alkane group and then there is a benzene present on it. So we can always write in terms of benzene as this way, isopropyl benzene. You can write it as isopropyl benzene, or here you can see cyclohexyl benzene. We can write this as cyclohexyl benzene. Okay. But if a double bond is there, then that will become the priority ring. So therefore, now the numbering will be 1, 2, 3, 4, 5. So it is 1 phenyl. Now this will become 1 phenyl. IUPAC wise, this will become 1 phenyl. Cyclopent 2-ene. Cyclopent 2-ene. Pent 2-ene. Okay. That would be the highest priority. Next one. Notice this is toluene. This is toluene. Let me write the correct spelling. Toluene. Toluene is the common name. The IUPAC naming is methyl benzene. Next, phenol. Phenol is the IUPAC naming. The common name is carbinol. The common naming is carbinol for phenol. Next, O-cresol is the common name if you have it ortho position, adjacent position. The IUPAC name is 2-methylphenol. Okay, this is 2-methylphenol. So I'm sure you can realize what will be M-cresol, what will be P-cresol. Ortho is 1-2 position. Meta is 1-3 position. Para is 1-4 position. Okay, so P-cresol means at 1-4 position. So you can see this is O-xylene. At ortho position, we have 2 methyl groups. So it is called O-xylene common name. The correct IUPAC name is 1,2-dimethylbenzene. 1,2-dimethylbenzene. If you have 3 methyls on a benzene with 1,3,5 position, it is called common name is mesitylene. The common name is mesitylene. And the IUPAC name is 1,3,5-trimethylbenzene. If you have benzene with 2 OH groups, that is called catechol. Okay, catechol is the common name. The IUPAC name is benzene 1,2-diol. Do not use the word phenol anymore. Phenol is different than catechol. Both of them are different functional groups. If you have multiple OH groups on a benzene ring, the functionality changes. Okay, one OH is a different function, two OH is a different function, three OH is also a different function. Clear, everybody? Okay. So two OH groups, if you have, you read it as benzene 1,2-diol. Okay, the common name is catechol. If it is at meta position, you do not use the word metacatechol or something. It has a different name. The common name is resercinol. The common name is resercinol. The IUPAC name is benzene 1,3-diol. And if you have it at 1,4 position, that is at para position, the common name is quinol. And the IUPAC name is benzene 1,4-diol. This is benzene 1,4-diol. Okay. So these are few important cases that you need to remember from benzene. In fact, on benzene, there are a lot more cases, but as you go towards multiple chapters, you will get to be introduced what are all the functional groups. Okay. The next one is next one is bicarboxylic acid, or if you have multiple COOH groups, what are the common names that are accepted as IUPAC names also? For example, formic acid, which is methanoic acid, but also formic acid is accepted as IUPAC name. Next, acetic acid. Acetic acid is only used as common name. The IUPAC name is ethanoic acid. Next one is butyric acid, common name. The IUPAC name is butanoic acid. 2-carbon acid is, oxalic acid. Clear? And if you notice the common name here, it is 1 comma 2. On two positions we have carboxylic acid, so it is ethane 1,2 dioic acid. Okay, ethane 1,2 dioic acid. Here it is 1,2,3 propane 1,3 dioic acid. That is the IUPAC name. Common name is malonic acid. If you have 4 succinic acid, if you have 5 glutaric acid, if you have 6 adipic acid, if you have 7 carbons, pimelic acid. Sorry, pimelic. 7 carbon pimelic acid. Okay. If you have same 5, 1, 2, 3, 4, 5, with one COH extra and one OH extra here, if you have that, that is citric acid. If you have 4 carbons like this with 2 OH groups, that is called tartaric acid. In compounds, in organic compounds, tartaric acid is the first acid which will explain the concept of optical isomerism. Okay, clear? So this was the first one which was introduced. Next one is malic acid, a 4 carbon with a cis form. Only the cis form is called malic acid, everybody. This is the cis form or cis isomer. The trans isomer or the trans form is called as the fumaric acid. Malic acid and fumaric acid. Okay. These are the important common names that you need to remember. Now you might ask, sir, abhi ke abhi yaad karna hai? Not necessarily. As you go through the chapters, you will be hearing the names of these words. Okay, you will always come across these words, correct? So there you need to realize, recall what is the name exactly. Okay, how does the functional groups are? Which are the how many number of carbons does it have? Correct. Now this is the complete list of compounds which are important ones along with their common names. Okay. So you can see here, those are the ones which I have written it. Valeric, caproic, oxalic, malonic, succinic, glutaric, adipic, pimelic, maleic, fumaric, which we have just discussed, lactic acid, tartaric acid, pyruvic acid, citric acid. These are all the acidic forms which you have written. Clear? And then nitrogen containing compounds, what are all the important names? Okay. And on benzene cases, what are the important names? Now, quickly, let me just go through it once. Here, you can see this is styrene, but when there is a double bond, outside is the main ring. So 1, comma 2. So on one position, we have phenyl. So it is phenyl ethene. So one phenyl ethene, correct? That is styrene. Common name, if you have two benzene rings connected, it is called biphenyl. The IUPAC name accepted is also biphenyl. This I told you, if you have two rings, then main chain will be the common, the straight chain. So it is diphenyl methane. The common name as well as IUPAC name is the same. Then the common name, if you have an ethene, is called as stilbene, stilbene or 1,2 diphenyl ethene. Next, we have chlorotoluene as the common name, orthochlorotoluene. The IUPAC name is 1,chloro-2-methyl benzene. You can use the toluene as the, you know, complete function also. But if you ask me, always try to see this one first in the options. In the options, IUPAC name is asked, always try to see in the form of benzene first. Next, bromobenzene, bromobenzene. Next, meta-dibromobenzene or 1,3-dibromobenzene. This is sim-tribromobenzene. It is called 1,3,5-tribromobenzene. Okay. Next, you can see this is phenol. On phenol, we have 2, comma 5, sorry, 2, comma 6. So 2, comma 6 dimethyl phenol. Correct. See, if you have three OH adjacent to each other, the name is pyrogallol. Very important compound, everybody. This I would want you to make a note of it. Okay. Because we will be coming across, multiple sections in chapters. Correct. Even in physical chemistry, you will keep coming across this one. So remember pyrogallol. Pyrogallol is a thick liquid solution which will absorb oxygen very easily. That's why it is used as an absorbent for oxygen. Okay. The IUPAC naming is benzene 1,2,3 triol, but the common name is pyrogallol. Next one, if you have three functional groups at 135 position, the name is common name is fluoroglucinol. This is called fluoroglucinol. The IUPAC name is benzene 135 triol. Okay. Next one, if you have an amine as well as methyl, you use the word toluidine. So by chance, if you come across this term toluidine, which means it is a toluene combined with amine. Okay, so that is why it is called toluidine. So the IUPAC naming is 4-methyl aniline. Aniline is the common name. Sorry, complete functional name that can be used along with benzene. So this is aniline. So here it is para-bromoaniline or 4-bromo benzanamine or 4-bromoaniline. Both of them are correct. Next, here you can see N,N-dimethyl benzanamine. N,N-dimethyl benzanamine. Now this is called O-phenylene diamine. O-phenylene diamine, or the IUPAC name is benzene 1,2-diamine. Okay. This is O-anisidine, or we can, the IUPAC naming is 2-methyl aniline. This is entire thing is aniline. So sorry, 2-methoxy. 2-methoxy aniline. This entire thing is aniline form. Okay. Next, in case if you have SO3H, that will become sulfonalic acid. Common name is sulfonalic acid. The IUPAC name is sulfonic acid with 2 amino and it is on benzene, so hence it is benzene sulfonic acid. Okay, so this is 2-amino benzenoic acid or benzoic acid, simply benzoic acid. The IUPAC, the common name is anthranilic acid. The common name is anthranilic acid. If you have two CHO groups on benzene, it is called phthalaldehyde. The IUPAC name is benzene 1,2-dicarbaldehyde. Okay. If you have one CHO, it is called M-bromobenzaldehyde, right? So, or it is 3-bromobenzene carbaldehyde. It is benzene carbaldehyde. IUPAC also uses this one, 3-bromobenzaldehyde. Got it? And now you see this one, if you have benzyl acetophenone, okay, this is benzal, you have benzyl acetophenone. This is benzyl acetophenone. The IUPAC name here is 1,3 diphenyl. So you can see this is 1, 2, 3. On 1 also we have phenyl, 3 also we have phenyl. So 1,3 diphenyl prop 2 in 1 on. So it is prop 2 in 1 on. Okay. Next one. If you have this one, this side there is an ester form, this side there is an acid form. So benzoic acid is the main functional group and this is a substituent. Okay. It is read as acetyl salicylic acid. Acetyl salicylic acid. That is the common name. The IUPAC name is 2-acetoxy benzoic acid. So it is 2-acetoxy benzoic acid. Clear? The common name, another common name which is very commonly used is aspirin. Okay. This is a very important compound, everybody. Even if you do not know here, you will be forced to learn here in multiple topics. You will come across this in multiple topics going ahead. So please make sure that you are aware of what is aspirin. Okay. Next one is methyl salicylate. Methyl salicylate is the common name here. This is methyl and this entire thing is salicylic acid. Okay. The IUPAC name is methyl 2-hydroxybenzoate. Methyl 2-hydroxybenzoate. Methyl salicylate also has a very common name used in pharmacy, which is oil of wintergreen. Okay, oil of wintergreen. Oil of wintergreen means nothing but a painkiller, surfacial painkiller, which is Relly spray, Moo, Volini. You might have seen these lotions, correct? Which we use it whenever we have sprains on the muscles, especially if you have any sprain in the muscle, we use that sprays or we use that as a balm. Okay, Jandu balm and what all we have, tiger balm, you know that all of those, right? So they all contain what? The main ingredient in them is what? Methyl salicylate. Got it? That is methyl salicylate. Next one, phenyl salicylate. Phenyl salicylate. You remove methyl with phenyl. Now this will have more antibiotic property and sorry, antiseptic properties. Correct? Dettol, right? Savlon, all of these antiseptic lotions. If you notice, those will have main ingredients as phenyl salicylate. Correct? IUPAC naming is phenyl 2-hydroxybenzoate. Okay. These three are very commonly used in chapter phenols. We have a separate chapter in phenol. These three are direct names that we'll be using: aspirin, oil of wintergreen, and salol. Okay. Next, DDT. DDT is the common name for a fertilizer. Correct. This fertilizer is now banned in India. We will not use this fertilizer anymore because it will erode the soil properties. Got it? But what is the name, IUPAC name? This is actually ethane. If you notice, this is 1, comma 2. On 2, we have ethane. Correct? On one position, we have 3 chlorine. So that's why it is called 1,1,1 trichloro. And on second position, we have 2 phenyls. So since there is already chlorine present on it, then we use the word bis. So 2, comma 2 bis 4 chlorophenyl ethane. That is the IUPAC name of DDT. Okay. This I want you to write and learn, everybody. What is DDT? direct JEE mains questions have been asked where the DDT structure has been mentioned, or you have to figure out what is the correct IUPAC name. So please note out what is DDT. Next one is TNT. TNT is used as an explosive. Okay. TNT is a liquid which is used as an explosive, which is nothing but trinitrotoluene. Okay. Of course, this is not as good as RDX, but this is, good enough to make small blasts. Okay. So TNT is used here. So which is trinitrotoluene. So you can see 2-methyl 1,3,5 trinitrobenzene. Okay. Next one. This is the most used in GOC. We'll be using this a lot of times. Correct. Picric acid. Very important acid. Picric acid. Okay. Picric acid is with benzene, with phenol. This entire thing is phenol with 3 nitro groups on it. So 2,4,6 trinitrophenol, IUPAC name. That is picric acid. Okay. Please write and learn, everybody, what is picric acid as well. One is DDT, the other one is picric acid. Last year, 2024, there was a question on JEE mains which is asked how many number of pi bonds are there in picric acid. How many pi bonds, everybody? We have 1, 2, 3 here. In nitro, there is one pi bond. 1, 2, 3 here. So total 6 pi bonds we have. Okay. What if the degree of unsaturation is asked? Then again you check out the pi bonds. 1, 2, 3, 4, 5, 6. 6 pi bonds and one ring. So total 7. Degree of unsaturation is 7. Number of pi bonds are 6. Okay. Any of these kind of questions that will come across, I think you should be ready. Clear? Done? Right. So these are the names, everyone. Clear? So if you ask me, the last things which I have discussed, which I have already given in the notes, few things you need to practice, whichever I have put it as a marked ones, you better practice them. Okay. So to starters as an IUPAC, this much is sufficient enough. Every chapter when we deal with it, we will come across IUPAC once again. But as a starter to check out GOC, isomerism, wherever we require the namings, this much amount of IUPAC naming is sufficient. Clear? Right.